Hey everyone, welcome back. This week we are diving into a new concept, threads. Threads are like the building blocks of multitasking on computers. In today's class, we'll learn about threads, what threads are and why they are so important. We need to look at differences of processes with single thread and many threads, okay? And then we also emphasize why do we prefer threads rather than having many single threads process. At the end, we look at different levels and models of multi-thread programming. So in the previous chapter, we discussed processes as single-threaded executing programs. So each process firstly is responsible to carry out only one single task, okay? However, in modern operating systems, process can have multiple threads. Having multiple threads in a process help us for multitasking, okay? So in the multi-threaded process case, operating system is able to perform many tasks simultaneously, which eventually enhances multitasking capabilities, okay? So threads are representing fundamental units of CPU utilization. They're consisting of a thread ID, a program counter, registers, state, and stack. In this case, if a process has 3 threads in its address space, then each thread stack can be represented like this, okay? So guys, look at this drawing before moving into more details, okay? And let's compare a traditional single-threaded process and multi-threaded process in this drawing. So every process has its own address space, okay? And in this address space, it holds data section, code section, open files, signals or signal handlers, okay? Threads within the same process share the memory and resources allocated to that process, okay? So if one thread modifies the shared memory item, all other threads within the process can absorb that change. Similarly, resources like open files are accessible to all threads, ensuring collaboration and data consistency. But you need to always remember that each thread have its own register and stack. So it becomes like this, okay? They all have its own registers and stack. And stack holds information about function calls and local variables for that thread, okay? So let's discuss the different states that threads can be in and explain the unique characteristic of threads within the same process in detail, okay? So threads, the fundamental units of CPU utilization, can exist in one of 3 states. In the running state, a thread is in this state when it's actively executing its instructions on the CPU, okay? It's similar like the two process states. Only one thread from a process can be in this state at any given time, and the CPU is currently processing the commands of this thread, okay? And threads in the ready state are prepared to execute but are waiting for their turn to run on the CPU. They are waiting for the processor to allocate time for their execution, okay? So these threads are essentially in a queue, waiting for the CPU to start processing their instructions, okay? So threads also may enter the blocked state when they cannot proceed after without some external action, okay? This could be waiting for user input, waiting for a specific event to occur, or any situation where the thread cannot continue its execution until a certain condition is met, okay? Okay, if you notice that there is no suspend state. Okay, so sorry. A process can be suspended. However, it calls suspending all threads belonging to that process. Okay, so suspending individual threads is not possible because they are all interconnected within the same address space and resources. On the other hand, when a process is terminated, it similarly results in the termination of all threads within that process. In other words, ending a process means stopping all the threads associated with it. Okay. In summary, we highlighted the interdependency of threads within the same process, emphasizing that they operate within a shared environment. The state of threads running ready blocked reflect their current status in terms of execution and resource availability, and any action applied to a process affects all threads within that process due to their shared address space.